Hello, I've had a question in for you Physics, Unit 3, Lesson 7, question number 2. Why do magnets attract other non-magnetic materials? So if we look at it, we know a magnet. The theory is that for a magnet, any magnet, it consists of dipoles which are aligned. So this is what we theorize is what's going on inside our magnet. So we have a whole bunch of these dipoles that have aligned, and because they've aligned, they've created that magnetic field north-south, and it looks like that. All right. Now, to specify with this question, it's for non-magnetic materials, this is only for ferromagnetic. All right, we're not talking about paper or pencils. It's going to be ferromagnetic, so some kind of metal. All right, like a nail, for example. So if we look at a non-magnetic, a ferromagnetic material that's non-magnetic. Not sure if I ever get this out properly. So if it's non-magnetic, what happens is that in this material, the dipoles are not aligned. So you'll have one like that, then you might have one going in this direction, then one like that. So they're kind of just lazy, kind of just loafing around in any which direction, you know. Kind of like an art class. Don't tell your art teacher that. I'm just giving the art teachers a hard time here. All right, so something like that. All right, so you have north, south, south, north, north, south, maybe north, south, south. So they're kind of randomized all over the place. All right, so all of a sudden, what happens, magic of the smartboard here. So if I put that together. So now if I take my magnet and go over here and go, hey, non-magnetic material, what happens is there's an attraction that starts to happen in here. And you'll find that the dipoles in here start getting attracted to these dipoles over here. They've aligned, so these dipoles are very strong, creating a magnetic field. And then all of a sudden, the dipoles over here in this piece of metal start feeling that magnetic field and start aligning themselves. So what happens, oops, I go down here. What then happens is that non-magnetic material, the dipoles start matching up because now all of a sudden the north ends of those dipoles are attracted to the one end. So they are under the influence of these dipoles, and then that magnetic material starts to align. So that's why the non-magnetic material is attracted to a magnetic material. So it's that influence of the dipoles from the magnetic material. Now, if we hold these magnets, or the magnet and the material side by side long enough, this will become temporarily magnetized. Temporarily, I'm not sure on the spelling, not my department, magnetized. So maybe I know, sometimes in grade 3 or 4, I forget which one it is, you do magnetic forces. Teacher may have had you take a magnet and a nail and kind of tape them together and leave them overnight, and then you come back the next day and like magic, the nail is all of a sudden a magnet, but it only lasts for a certain period of time. The nail loses its magnetic properties and no longer is a magnet after a while. So those dipoles in here, they align temporarily, depending on the material. That'll influence how long, but that's why magnets attract non-magnetic materials. But again, to specify, it has to be ferromagnetic materials, not just any material. So hopefully that ramble kind of clarifies the answer to that question. If you have anything further or any follow-ups, let me know.